delays. So, in real circuit, logic gates have delays with them. There are delays associated with them. Gate delays allow the Verilog user to specify the delays through the logic gate. Means through the Verilog code, we specify the delays. Otherwise, it will take the default value, whatever is specified in IEEE Verilog standard. So, it is for externally, if in order to specify the gate delays, we have the provision available with Verilog. Now, pin-to-pin delays can also be specified in Verilog. Now, what are the pin-to-pin delay? In order to move from one pin to the other pin in the ASIC, what is the delay? It's called the pin-to-pin delay. There are three types of delays available with us. That is rise delay, fall delay and the turn-off delay. Rise delay. So, the rise delay is associated with a gate output for transition to a 1 from another value. O, X or Z, in order to transition from O, X or Z to one value, that is the T rise, I have the rise delay available with me. So, the rise delay is associated with a gate output transition to 1 from another value. Now, what is the fall delay? Fall delay is associated with a gate output transition to a 0 from another value. 1x or z to 0. What is the time taken in order to transition from 1 to 0? Is called the T fall. That is the fall delay. Turn-off delay. So, the turn-off delay is associated with the gate output transition. When the gate output transition happens to the high impedance value, that is Z, from any other value, that is called the turn-off delay. If the value changes to X, okay, the minimum of the three delays are considered. So, there are three types of delays. Types of delay specification. So, delay time for all transition. Just see, here is the AND gate and I have mentioned hash bracket delay time A1 out comma R1 comma R2 semicolon. This is the AND delay. Rise and fall delay specification and hash rise val comma fall val, that is A2 out I1 comma I2 semicolon. This is the rise and fall specification. That is a type of delay. This is the rise delay, fall delay. So, that is what it has been said. If the value changes to minimum of the three delays considered, means if the delay value changes to X from Z, what is the minimum value of the three delays? That is the rise, fall and turn off is considered. So, I specified how to write the delay time in Verilog code. Now, I specify how to write the rise and fall delay in the Verilog code. AND gate, it is a primitive gate. Along with the primitive gate, I am specifying the rise value, comma and the fall value. A2 out, comma I1, comma I2, semicolon. Now, here's the rise, fall and turn off delay specification. So, here is the gate buff if 0, buffer if 0. So, instance name is B1, out is output out, in and control. Okay. So, along with this buff if 0, I am specifying the rise value, fall value and the turn off value. Rise, fall and the turn off delay specification. Examples of the delay specification shown are and hash 5 A1 out comma I1 comma I2 semicolon. Delay of 5 for all transitions. Here I am providing a delay of 5 for all transition. Then I am providing in order to have the rise delay and fall delay 4 and 6. So, and hash 4 comma 6 bracket close A2 out comma I1 I2 semicolon. So, A2 is the instance name of AND, out is the output and I1 I2 are the two inputs of the AND gate and 4 and 6 is the rise delay and the fall delay. Now is the buff if 0. This is the primitive gate. Instance name is B1. Out 1 is the output. In and control are the inputs. 3, 4, 5. Rise value 3. fall value 4 and the turn off value 5. 3, 4, 5. These are the 3 delays for the buff if 0. Minimum, typical, maximum values. So for each type of delay we discussed, that is the rise delay, fall delay and for the turn off delay. For each of them I have the 3 typical values. Minimum, TYP typical and max, MAX max. What are these? So mean, tip and max values are used to model devices whose delays vary within a minimum and maximum range. They are used to model devices. Okay, model devices mean model gates. Okay, within a minimum and maximum range. The delays are specified within the minimum and maximum range because of an IC fabrication process variation. Means when the IC is very fabricated, so during the fabrication process, every time I cannot assure a particular value of delay. There is a range in which it varies. That is the minimum and maximum. And typical, I think so, it is the average value you can take from minimum to maximum. So mean is what? Mean value. The mean value is the minimum delay value that the designer expects the gate to have. Minimum value, that is necessarily the gate should have. Typic value means tip. The TYP tip value is the typical value that the designer expects the gate to have. The minimum value is the minimum delay that the designer expects the gate to have, and TYP tip value is the typical value designer expects the gate to have. And the max value is the maximum delay that is possible, that the designer expects the gate to. Maximum value, the maximum delay that the designer expects the gate to have. So minimum, typical or max value can be chosen at Verilog, at runtime also. At the runtime also we have the provision in order to include the mean, tip or max value. Okay. Else we can write while writing the code also. For Verilog Excel, the values are chosen by specifying option. They are specifying option. Plus max delays, comma, plus tip delays and plus mean delays at runtime. While invoking the Verilog file, no, we can, at the command line, we can write plus max delays, plus tip delays and plus mean delays. So these values will be included at Verilog runtime. The designer can experiment with delay values without modifying the design. Now I am not changing the design, but the default value of max, default value of tip, default value of mean delays I am changing through the command line. For 2 delays, earlier one was for example for 1 delay. What is the minimum mean delays? What is the minimum typical delays? And one is the minimum, what is the maximum delays? Mean delays, typical delays and max delays. So I specified it. So this signs means what are the 3 types of delays. If there is no sign, only 4, that is only the default value I am providing. Okay. Now 2 delays. Now earlier one was 1, here is the 2. For minimum delay also I have rise and fall. For turn off, there is a range of minimum 3 to 5. For typical delay, I have 4 to 6. 4 is the rise, 6 is the fall, and the turn off delay would be what? It would be between these two, minimum of 4, 6. If plus max delays, rise is 5 and fail is 7. And the turn off, it would be the range of 5 and 7. So while writing it, first of all, I will write the rise of all the delays. Minimum delays, typical delays, max delay. That is 3, 4, 5. All separated by colon. Then comma, I will write the fall delays. 5, 6, 7. All separated by colon. And A2 is the instance name. Out is the output. And I1 and I2 are the inputs of the AND gate.